is on Mars?
The key objective of the Mars Science Laboratory is to search for signs of ancient habitats. And so the rover will rove up to areas that had been soaked in water in the past and may have trapped organics. So if we find those kind of layers, we can go up to that kind of a rock and we can drill into it and take the material from inside the rock and tell with a lot of precision what the rock is composed of and whether there's organics in there.
The Mars Science Laboratory will be one more link in a chain of exploration to understand that bright red dot in the dark night sky. Put together all the new evidence, and it adds up to the need for more evidence.
We don't know how the magnetic field was lost. We don't know exactly how the atmosphere was lost. We don't know where all the water went. We don't know whether the methane is produced by life or just regular abiotic chemical reactions.
But maybe questions that baffled the 19th and 20th centuries will be answered in the 21st.
I asked 5 other Mars scientists, what percentage chance would each of you give that life ever formed on Mars? 4 of us thought it was maybe greater than 90% chance that there had been at some time and maybe now life on Mars. And 2 of us thought it was less than 15%. And the follow-on question then is, if you think that there's less than 15% chance, is it really worth going to look for it? And the answer was immediately, absolutely.
I don't think that rovers and landers and orbiters are going to find life on Mars. My personal opinion, I think it's going to take people. I think there will come a day when people go to Mars, digging and drilling and thinking and just going with context and gut feel and putting the pieces of a very complicated puzzle together. I'm optimistic that we're going to find evidence of past or present life.
In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious and blowing the deadly secrets of a place we call the universe. They've already wiped out the dinosaurs and many other species, and there's no doubt they will strike again.
It would be a disaster far beyond biblical proportions.
Investigating asteroids isn't just about science.
Asteroids are going to be one of our biggest problems for humanity.
It's about survival.
So the smarter we can get before then, the more we can figure out, can we do anything about it?
Get ready for the latest asteroid discoveries and daring new plans to go where no man has gone before. It's the year 2029, and an asteroid that scientists have been tracking for decades is passing close to Earth. The asteroid is about 3 football fields wide. Its name is Apophis, after the ancient Egyptian god of destruction. According to the latest predictions, Apophis won't hit Earth in 2029. But as it passes through a seemingly nondescript area of space nearby, the world's scientific community goes on high alert.
Astronomers have calculated a very small region of space, which if Apophis happens to go through that region, then it will be set up for a collision with Earth in 2036. And this very, very tiny region, which is less than a mile across, just a few thousand feet across, is called the keyhole.
An international cooperative of space agencies launches a rocket to take on Apophis.
Now, you don't want to blow it up with a nuclear weapon. First, that would take a lot of energy, and it would just produce a huge number of fragments all heading toward the Earth. What you really want to do is give it a bit of a push that slightly changes its trajectory. That way we don't get a collision.
But it's possible that the 30 million ton space rock could simply be too massive. The collision hasn't knocked the asteroid far enough off course. The impact in 2036 is thousands of times stronger than the atomic bomb dropped on Hiroshima. The immediate crater is as wide as the island of Manhattan.
It would create a crater over 2 miles wide. If Apophis were to hit a city, goodbye to that city and the surrounding region for 100 miles.
From the shockwave, the blast, the winds coming out, from the impact ejecta, and from the massive earthquake equivalent that would occur, that would reach out and be felt over huge areas.
When Apophis was first discovered in 2004, the initial odds of an impact were about 1 in 37. But those odds have been dropping over the years, as scientists have obtained a better look at its path.
You can make the analogy that the orbit determination process is similar to predicting hurricanes. When a hurricane first starts out, you don't know exactly where it's going to go. And as you get more and more data in the next week or two, you can refine your predictions. And so it's very much like that with asteroids and comets. The more observations you get over time, the better you know where the object will be in the future.
That's why today's odds of an Earth impact, only 1 in 250,000, are so much slimmer than the original 1 in 37 prediction. But even if Apophis doesn't hit Earth, there's no doubt that something else eventually will. It's a disaster that space agencies take very seriously. In July 2010, a NASA advisory panel recommended the creation of a planetary defense office to figure out how to detect and deflect any asteroids heading our way.
We know for a fact that an asteroid is going to impact the Earth sometime in the next 1 to 10,000 years, a big one. And it's a good question as to when it's going to happen and are we going to be ready for it when it does.
A seaside amusement park is an unlikely place to demonstrate how asteroids and comets speed around our corner of the universe. But an arcade attraction here actually reveals a lot about these deadly objects.
Our solar system is kind of like a shooting gallery. Asteroids and comets can occasionally hit planets and moons, creating gigantic impact craters. Now, the bigger objects present a larger cross-sectional area, so they're easier to hit. In this case, I actually have to hit these little bullseyes, which are all about the same size. But imagine that the man over there is Jupiter. He's big. And the chipmunk might be the Earth, smaller. And these ants might be our moon, even smaller. So Jupiter is pretty easy to hit. Earth, the chipmunk, is harder to hit. It's a smaller cross-sectional area. Ah, there it goes. Earth was hit. The ants are small, so they're even harder to hit. Most of the asteroids miss. Only occasionally do they hit.
But unlike the shooting gallery, where the bullets, or in this case flashes of light, always travel in straight lines, asteroids and comets curve toward their targets.
Jupiter tends to draw in the asteroids and comets through its gravity. So it's kind of like if I start with my aim way over there, Jupiter pulls the barrel of the rifle toward it, giving me a direct hit.
Since Earth is much less massive than Jupiter, its lower gravity doesn't draw in as many asteroids. And the Moon, with only a fraction of Earth's gravity, attracts even fewer. But as the Moon's crater-pocked surface illustrates, infrequent asteroid impacts over a long period of time still means plenty of destruction. Jupiter's ability to pull in comets and asteroids has been on display a lot recently. In 1994, the Shoemaker-Levy 9 comet fragments pounded Jupiter. Scientists thought this kind of large impact was a rare event, something to be seen once every few hundred years. But then,